Okay, so for today's activities, tasks, you're going to be asked to answer some word problems. And you're going to do this by drawing graphs and analyzing your graphs and the motion. So I'm going to do a couple examples for you, and then you'll be asked to do similar things on a worksheet. So the first one here, it says a car accelerates from rest to a speed of 28 meters per second in 20 seconds. You'll notice that it's not asking for anything specific. What I want you to do is to find as many things out as you can for each of these situations. And I want you to draw at least 3 graphs and diagrams to help you solve these problems. So, and I also want you to write down stuff you know. So for instance, it starts from rest. So we could say the initial velocity is 0 meters per second. So that's one thing we know. Another thing is it ends up at a speed of 28 meters per second. So we could say F for final, 28 meters per second. And we know it travels for a change in time of 20 seconds. So that's the stuff we know. So it's accelerating. So I could sketch an acceleration time graph. So I could go X, which is meters, time, which is seconds, and this is going to be a parabola. And at this point, I don't know anything else I could put on this graph, but I do know this final time is 20. So there's one graph. So that's one thing you could do. Another thing you could do, by the way, before I go any further, you can do this on graph paper. If you have it's good to have graph paper. I should have asked you guys or told you guys to get graph paper this year. That can help draw graphs. Okay. So that is one thing. I could do a velocity time graph. I'm pretty sure there's no negative velocities, so I'm going to draw my axis like this. So time, seconds, velocity, meters per second. So it starts at rest. So let's get a different color here. Starts at rest and accelerates to 28 meters per second, 20 seconds. So I'm going to go like this. Something like that. So that's 20. And this value here is 28. That's what you've been told. Okay, now we can start doing some more analysis. We could calculate the slope of this line. So slope is delta V over delta T. So that's 28 minus 0 over 20 minus 0. So that is, let's get out my calculator. 28. I knew it was 1.4. Didn't need to do that. 1.4 meters per second squared. That's acceleration. The slope of that velocity time graph is acceleration. So there's one new thing I found. I could also find the area under this graph. That's easy to calculate. Area will be 1/2 delta V times delta T. 1/2 base times height. So that is 1/2 28 times 20. So 28 times 20 is 560. Half of that would be 280, but just to be sure. Well, I know that as well. 280. So that is 280 meters, and that is the displacement. So we got a couple things. We got displacement. I think we kind of know everything, but I want you to do 3 different graphs. So what's another graph? I could do an acceleration time graph. So I could do this graph here. So times in seconds. Acceleration is in meters per second squared. And this has constant acceleration of 1.4. So it goes something like this. And that's 1.4. We could even, and I could even go like this. I know that, and this is 20. And that area is 1.4 times 20. That is 28, and that is that's the change in velocity. Sweet. That's it. That's everything you could possibly do for that question, I think. Oh, we could also do a motion map, actually. We could do a motion map. We could do something like this. Starts from rest, speeds up. Something like that. 0. This would end up at 280. So this is 280 meters. These are the velocity vectors. These arrows represent velocity. And you could say that v is equal to... actually, I'm not going to do that. There's your motion map. Okay, that's everything we could do for that particular question. Okay, here is a different problem. This looks like constant velocity. Car A starts at 20 kilometers mark, travels 80 kilometers in 60 minutes. Car B starts at 0 kilometer mark and travels 100 kilometers in 40 minutes. So that's, I think, a really useful graph in constant velocity would be the position time graph. So let's do that. So this is going to be time and... Okay, what units are we going to use here? Minutes? Minutes? I feel like we should use hours. We could do kilometers per minute. Yeah, well, let's do kilometers per minute for now, and then we convert some numbers later on. This is position in... We're going to use kilometers. Okay, car A, I think I'll do 20, 40, 60, 80, what is it? 100. Okay, car A starts at 20, and minutes, we got minutes here. 60 minutes. We do 5, 10, 15, no, that's too much. So we do 10, 20, 30, 40, 50, 60. Okay, car A starts here, 20 kilometers at 0, and then travels 80 kilometers. So 20 plus 80 is 100. So it's going to get to 100 in 60 minutes. So it's going to go right there. So that represents car A. Car B starts here. It travels 100 kilometers in 40 minutes. So 0 plus 100 is 100. And that does that in 40 minutes. Okay. So there's a position time graph for our two things. We notice that they meet at some point. It looks like 20, but I'm not 100% sure. We could say they meet at, it looks like around 48 kilometer mark. At around 20 minutes. Let's figure out some velocities here. Slope of this, slope is equal to VA, which is delta X over delta T, which is, oh no, that's VB, sorry. So that's 100 over 40. So that is, well, what does that work out to be? Like 2.5 or something like this? So that's 2.5 kilometers per minute. We'll change that later, but that's because that's kind of a weird unit. Okay, this one, VA, is equal to delta X over delta T. And it changed 80 kilometers in 60 minutes. So 8 over 6, that's 4 over 3. That's 1 1/3. So that's 1.33 kilometers per minute. We could double check that just to make sure. 80, 60. Okay, looks good. All right. Okay, at some point they meet here, and that's XM. I'm going to call that XM meeting point. So we could try to figure out what that point is. There's a few things we know is we could say for the car A, let's do this. VA is equal to delta x over delta t. So that means delta x is equal to VA delta t. In this case, delta x is xm minus 20. That's equal to VA times delta t. So I could write this as xm equals VA delta t plus 20. So that's an expression for that meeting position. And I don't know what xm is, and I don't know what the delta t is. It's somewhere close to 20, but I don't know what it is. But we could do the same thing for the car B. So car B, VB is equal to delta x over delta t. So delta x is VB times delta t, and that's xm minus x. So the starting position of car B was 0, so that's delta x is xm minus 0 equals VB delta t. So xm equals VB delta t. So now we have two equations for xm, and we have two unknowns. That means we can solve this problem. So this thing here, like blue xm, is also equal to red xm. They're the same thing. So I'm going to write that out. VA delta t plus 20 is equal to VB times delta t. So now what I'm going to do is I will subtract. What am I going to do? I will subtract. I'm going to subtract this from both sides. So I get 20 is equal to VB delta t minus VA delta t. There's a common factor delta t there, so I'll distribute that out. Then I'll divide both sides by VB minus VA. That cancels out, so I get delta t is equal to 20 over VB minus VA. And I can calculate that. That's 2.5 minus 1.33. So the time it takes to meet is at 2.5, 1.33. And I'm going to go 20 divide that. 20 divided by that. I get 17.1. Coolio. So now we know this number is actually 17.1. And we can also calculate xm. Xm is VB times delta t. So that's VB was 2.5 times 17.1. That's 42.9 meters. Coolio, that's 42.9. Oops. Awesome. Is there any? Oh, the last thing I said I was going to convert this into units that make more sense. So VA is 1.33 kilometers per minute. Let's change that to hours. So there's 60 minutes in 1 hour. So 1.3333 times 60. So that's 80 kilometers per hour. And VB 2.5 kilometers per minute times what it was 40 minutes? Yeah. No, sorry. Times that by 60 minutes per hour. So 2.5. So I guess that's 90 kilometers per hour. Just to double check. 2.5, 60. Oh, it's 150. Well, that's really fast. Whew. There you go. Everything's done on that one. Okay. So try the worksheet. Do as many graphs as you can. Find as many things as you can.